It's a miracle. Okay, so we can start talking. What is a cloud? This is the nature of the conversation. It's going to be wide-ranging. What I want to do is make sure that we can go through all kinds of angles. This is the only corporate slide. You're supposed to applaud there, right? This is the only corporate slide. One of the interesting things today is there's going to be a bunch of talks. If we look up here, I'm going to speak, and there's going to be something about Azure Stack, but Terraform, right? So this conversation is going to be relative to that kind of thing. But then there's 5 years of Kubernetes and looking to the future with Peter. That's also relevant. This is a good situation to talk because we're going to talk about it. Who am I? I am a human first. I can be no other. That's the only way to be in this world. I'm formally a principal program manager in the cloud compute team at Microsoft. That is important because I work and report through the AKS team, Azure Kubernetes Service. That is an upstream managed service of Kubernetes, and you may have heard about that. But it's one of many fantastic managed Kubernetes services and unmanaged Kubernetes services in the world. It is a great place to be alive, great time to be alive, right? We do work where we have these tools like Kubernetes, and we just didn't have them before. And it's not just us. It's not just some big company that has these tools. You do. You do. Everybody does. That's what open source software provides, and that unleashes everybody's creativity, everybody's ability to do work. This is a great time to be developing software, to be operating software. It really is exciting. Formally, I work on the PM team. People usually ask what that means. Because I'm upstream, that means projects. So I am or was the PM for Helm. There was Helm Summit the last couple of days here, just in this same venue, which was wonderful. It was a great way to share Helm and Helm 3 and news about it. I don't do Helm actively anymore. My colleague Bridget is in the front row, and if you have Helm questions, you should tackle her. Not me, thank you. We do other projects that you may or may not have heard about, Draft and Brigade. These are useful things. If you want to know, let me know. But some other things that we're doing more actively, the Visual Studio Code Kubernetes extension. We just passed. If you don't know about it, I'll be glad to show it to you. You really should investigate it. It works everywhere on any cloud, and there are a couple of things we can show, but we won't today unless you grab me outside. That one has got more than 1 million downloads. It's very useful. It's open source, and you should contribute to it. And you can build custom extensions that sit on top of it for your own environment, which is nice. And then finally, I do the Cloud Native Application Bundle, CNAB. How many people have heard about CNAB in some kind of weird way? I'm expecting like 6 of you so far. Yep, we got about 8, so I feel like I'm doing good. This is something that I'm working on right now. It's a foundation. It is a project of a foundation called the Joint Development Foundation under the auspices of the Linux Foundation. So that's another thing that I do. That is it for the introductions. But if you have any questions about those, let me know. So we're going to talk about what is the cloud, but we're going to do the reverse, because if you have to have a cloud, when you look at the sky, if there's no edge to the cloud visually, what is it? It's an overcast day, right? Like there is no cloud when it's raining all day. Like you don't speak of it. The metaphor doesn't work. There's no cloud when the sky is completely gray at the end of January, right? Like the metaphor just won't work. So to get to an idea of cloud, we have to talk about what an edge is. And so today what I want to do is talk about whether there's a Kubernetes thing that is cloudy, right? I want to talk about what the edges of the cloud are. And based on a few things that I say, I'm going to say, well, what can we do here? Which feeds in fantastically, especially to Eldad's and Peter's conversations this afternoon, right? I'm not going to propose the solution, but set up a series of situations in which we can have a deeper conversation. But you should interrupt me at any time and be rude and wonderful with your questions. I'm not kidding, right? These conversations we all contribute to. All right. So how to think about Kubernetes. So one weird way to think about this is especially so how many people are willing to say they're as old as I am? I'm 50. Are you in that range? You are a courageous person. We are courageous people. We're proud to say we've been around a while. And of course, what that means is we've had a lot of experience. Experience is another happy, positive word for failure. Having survived failure is what we call experience, right? So you could think of experience being the marketing term for having survived failure. We have had, if you're older, if you've had experience, we have had cluster management, right, for a long time. We've been building data centers in bare metal for a long time. Then we built data centers using VMs on bare metal for a long time. Kubernetes and the ability to scale out, scale in is not new. The tools as a system, as a structure is not new. What is new is that Kubernetes layers up the abstraction to containers and you can run it at home. That's new. Yeah, you're looking at me with that face that says, no, 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 I am not. But you could, right? How many people have dorked around with Raspberry Pi clusters? About a third of you to a half of you. Yes. That's what you can. That's what Kubernetes does. All of the systems knowledge that was gleaned in the last 30 years, funneled through the web, originally at Google, but not only there. That experience and those patterns come out in Kubernetes, and it's for everyone. That means that you can be as agile or as powerful, if not more so, than somebody like Microsoft, somebody like Google, somebody like Facebook, OVH, Alibaba. These companies are well funded for certain things, but not to be you. Only you can be you, right? So if you have your idea, you think you want to build it, you can use Kubernetes to do it, which is what we're doing too. That gives everybody the opportunity. So it's tremendous, even though it has problems. Some of the problems will be at 420. You can see the hard part. So there are issues, right? But it's still perfect. So it is the platform on which we're going to work in the future. And I'm pretty sure Peter is going to start with something like that. It's the platform on which we're going to work in the future. It's the ground. It's that we refinish the floor of this auditorium, but now this auditorium can be better. It'll be more pleasant to be in. It'll be firmer when you go dancing. It'll be, everything you do will use a better floor. That's what Kubernetes is. But we solved problems, and the thing is, we search out and we help fix pain, right? Kubernetes was pain in some sense. It's a solution for a painful place, right? Basic functionality is still a pain. So how many people think that you don't really need mutual TLS between services in Kubernetes, really? Yeah, nobody raise their hand, please, please. I don't want to make fun of anybody. That would be wrong. Why in the world does Kubernetes not have mutual TLS? Well, what do people ask for? They say, oh my gosh, I need a service mesh. Service mesh. Wait, I said it again. Service mesh. But they don't really need a service mesh. What they want are things like mutual TLS, and service meshes are the things that make that happen, right? So this is a pain point. Service mesh is a signal that basic functionality is still not there. It's not a thing that should remain there forever in that world. Another one are CRDs. So CRDs are a great way to interact through the Kubernetes API to extract some functionality in a structured way that should also be there and we've already solved, right? So when you build an operator, which is a great way to take something that already works at a VM level, right? Native code, it's a server, daemon, something we already know, but you don't actually have to rebuild it as a distributed app. You can just put a CRD wrapper around it, throw some metadata in the API server, and you're good to go. Boom. Now you have black boxes in the middle of your Kubernetes, and it feels good because you can use it, right? And it feels good because your tools can see it. But do you know what's running in it? Not so much. What if that CRD is stomping on another CRD? Yes, sir. You were absolutely right to ask. What is a CRD? It is a custom resource definition. Now, that's a fancy word for a bunch of metadata that is not upstream in the Kubernetes project, so it is not surfaced in a typed way in the API as an object, except to say that it's a CRD. And the Kubernetes API server knows how to talk to that CRD to extract whatever metadata that CRD wishes to return. Does that help? Okay, that's absolutely, you should please interrupt me because it's easy to use jargon accidentally, right? But a CRD exists so that we can run something that's not Kubernetes in Kubernetes. Architecturally, does that feel right? If we like Kubernetes as a distributed computing platform, and we think it's going to be here for 5, 10, 20 years, that doesn't feel right, even though it does work. So that's an interesting area. It's evidence of pain. Kubernetes itself doesn't move fast enough. We have to add little black boxes and traps. And of course, there's the gorilla in the room. This last one, second to last, penultimate, solving compute complexity. What we did is we put your process, I'm looking at you because you're strangely not asleep yet. We said, you're close, okay, I'll try. We put processes, native processes, in these beautiful things called Docker containers. Does everybody remember how wonderful it was the first time you did Docker build, Docker run? Like it was like that. On Windows, I'm so sorry for you. I probably owe you money personally for that pain. You'll send me an invoice later. Okay, fine. In reality, that's an interesting conversation. If you want to ask me about that situation later, feel free. I'm happy to talk about it. But the point is, it was beautiful when you jumped to Linux, where it was working, right? Okay, this is computing, the genius of a beautiful tool. Okay, the genius of a beautiful tool is that it makes your heart go flutter because it's useful, right? And Kubernetes does that at scale for us, right? And now it does it at scale for Windows containers too. I bet you did that a while ago. Yeah, you did. Okay. But the problem with making compute easier is that pushes off. We talk about configuration as code, right? The reason we have YAML is because we don't write imperative code to do the same things. And we think that's a great thing because it is for compute, right? If you want to run a process, it turns out it's easier to just say, I never touched that manifest, it keeps working, or my Helm chart, it keeps working. But the compute gets easier, and we love it. Guess what gets harder? Configuration. Because we've now said everything that's happening in code is now configure. That line hides more pain and problems for the future than we suspect right now. I like that theme song. So then edge, right, is all of a sudden a different thing. Let's talk about this metaphorically. This is a container, right? You've seen this before. We're going to call this Docker, right? This is a Docker host. You notice your Docker host, you've got to drive up to it and give it a container, right? There's no system here. There's you get on the truck, right? So that's a Docker host. Lots of containers, no problem. This is Kubernetes. Now you have a tool that can carry all these containers in an organized way. All right?
Where's the cloud?
Good question. Because now you have these container ships, these clusters all over. And now, metaphorically, what are these things up here, the loading devices? And you can see one ship is coming in while another ship is going out. Those are orchestrators. These ports are orchestrators. The ships are cattle. The clusters are cattle, right? Metaphorically, what we realize now is there's edge, and there's edge. So we're looking for the edge of the cloud now, right? So notice I started, and you asked me, like, what's the cloud? Well, now I'm looking for the edge. What is the edge? Well, we now have clusters as cattle, and we're going to need to manage the cattle. So now we need to have orchestrators for clusters. This morning, there was a great talk and a demo, and they were waiting up here, and I was in the back when I arrived the first time, and they were waiting for Azure to create a cluster. And somebody asked, how long does it take? Were you here when you did? Okay. And I was sitting there going, well, he's going to say 3 minutes, or he's going to say 37 minutes, right? And he said 5 minutes. Which is about average for cluster creation in Azure. Now, some services create clusters a little bit faster, some services create clusters a little bit more slowly, but that's not really the point. They're in the ballpark because all of these companies are great companies. Not just Azure, but other companies are great companies too, right? What's interesting here is now the clusters are cattle. You can pop a new cluster in 5 minutes, or 3.5, or 7. It doesn't matter because you're now popping 1,000. And then you'll get rid of them when they're done. Potentially. Now everybody knows the real world doesn't work quite that way, but potentially it does. So, wow, now we have cattle. Well, you can make those cattle smaller, and we have a couple of things. How many people know about Kind? Kubernetes and Docker. Actually, okay. If you don't know about Kind, Kubernetes and Docker, look it up. It's wonderful. It is one of the most agile, useful, developer-oriented tools for Kubernetes. You should use it immediately. Please do. It's not me or anything. It's completely open source. It's fantastic. It is a whole Kubernetes cluster of your own configuration and as many nodes as you want, hosted in a Docker container. Boom. Right? Now think about that, but that could go anywhere. You think about it as developers or operators, you think about it on this computer right here. But that's not actually the situation. What I want to know is, if I've got a container that I can run on Raspberry Pi, can I put Kubernetes on the Pi? The answer is yes. Didn't used to be. So there's another one that's done by Rancher I love. I use it very similarly, although it is not exactly implemented the same way, and that's K3ds. How many people know about K3ds? A few more. Rancher's done a good job. Rancher, are you here? No, not actually here, but they're out there. Okay. So I love this, right? I don't work for them. I work for Microsoft, the big machine, right? But I love this. I love K3s. You should. So you can run cattle in small places because they're actually smaller cattle. They're like Shetland ponies, right? That's fantastic. So let's chat about examples. So what is our edge, right? So let's say edge, the little teeny edge, I'm going in a reverse size, is like a CPU, and you have a possible container runtime. You probably have networking. You can connect. Note, this is not something I'll talk about in a second. Then there's edge with a capital. You've got CPUs, right? And possible clusters, and you connect to those little edges. So this might be a local data center, but it also might be something like, here's an example. An unnamed cell phone company wants to put in 2 Kubernetes clusters with 4, 5, 6 nodes, each on every cell phone tower, which means their cell phone towers become compute centers. But it's not a DC. Now that's interesting. Your work could run there, or you can take that idea and run it yourself. But it's not a cloud, is it? Or is it? Then there's edge, capital edge. These are small DCs, DCs being data centers, right? It's because I'm too tired to say data center every time. So I say DC. Disconnected DCs is basically Kubernetes everywhere. That's the platform. It's the new floor that we have. We get to share, right? There are cruise ships running around the world with an entire fully functional data center that could only have been supported by a major corporation, like say 10 years ago. And they don't connect. They run everything on the ship. The ship has tons of sensors. So for example, the ship is the edge. Then they have edges, and then they have edges all over the ship as well. So which one of those is a cloud? Well, it kind of gets attenuated. Finally, is there really an edge? Or more to the point, what's not an edge, right? What is not an edge is the thing I didn't mention. Originally, when we talked about edge, we talked about sensors. the little teeny chips that just say what the temperature is, right? Or detect motion, or examine a camera for pixels. That's it. They don't do anything else, right? And they send outbound information. They don't take inbound information. That's not the edge. Those are the leaves, is the way we look at this. I'm up for argument. But if there's no edge to the cloud, this is the scary part, right? Now, I'm using this as a way of expanding our mind about the reach of Kubernetes. But it's really talking about the reach of computing and software, right? And Kubernetes is the floor on which we can build each one of these larger and larger edges, larger and larger clouds, depending on how you'd want to define cloud. But ultimately, the world is going to be a cloud unless we have a problem communicating between all the edges, which is always an ever-present issue. And we don't have to talk about too much. The world's politics are full of challenges to our interconnectivity, not just on a technical level, but on a human level. So it's a difficult problem. We hope to continue to solve it because we can do better together, not just as companies, but as software developers in open source everywhere, and also as people. So, this is, of course, The Hitchhiker's Guide to the Galaxy. Does everybody know The Hitchhiker's Guide to the Galaxy? If you don't, it's okay. The shtick of this slide is that a superior race decided to build a computer to calculate the ultimate answer to the ultimate question of existence. And it turns out in the story, the computer is the world we live on, that we are the computer, right? That's the optimistic spin on the title, because you can imagine the title might turn in a dystopian way if we're not too careful, right? The world is the computer, and that means that there is a cloud, it's us. Now that sounds really kind of highfalutin, but it's really, when we talk about a technical level, we're talking about the gradations of the edge, and Kubernetes is present in all these places, which gives everybody amazing reach, amazing opportunities. It's a great time to build software. But Kubernetes is hard, and you need to look forward 5 years. And this talk is meant to start that thinking. Usually at a meetup, at a conference, at a conversation, we talk about the technology. And I want to open up and talk about what we could do with it rather than, strictly speaking, the software bits itself. Thank you very much.